Hi Algebra 1. You get to learn how to solve quadratic equations. A quadratic equation is what we've been solving, or a quadratic expression rather, but a quadratic just means that the highest exponent is 2. And we talked about that, remember, quad means 4, and when we say like x squared in translation, it kind of got messed up because a square has 4 sides, and that's why it's called a quadratic, because quad means 4, but blah blah blah. So solving quadratics. So far all we've been doing is factoring. But remember, when we solve something, that's when you say x equals this. So keep that in mind. If the directions say to solve, then that means we actually have to tell you what x equals. There's also a very significant difference in these problems than what we've seen before, is that there's an actual equation. If you notice all the ones we've done before, there aren't any equals signs in them. They're just expressions. And that's the difference. The difference between a problem where you solve what x equals and where you don't is if there's an equal sign. So I'm just going to write on here and then I'll erase it. But if I have x squared plus 5x plus 6, that's just a factoring problem. But if I have x squared plus 5x plus 6 equals 0, now you can actually tell me what numbers x can be. So that's kind of cool. So that's the main difference you need to remember. And it doesn't seem that complicated, right? The difference between what's on the left and what's on the right. It's an equal sign, just having that. But people tend to get confused on that. But you can do it. I know you can. So this whole lesson is built on this idea that if I have two numbers that I multiply together and I tell you that they equal 0, like if I think of a number, let's say it's 4 because it's my favorite number, and someone else thinks of a number 10. No, wait. Pause. Someone else thinks of another number, we don't know what it is, but I tell you that when I multiply the two numbers together, you get 0. Well, then what's one of those numbers? 0, because that's the only way for that to happen. Now, what if I didn't tell you what either of the numbers were, but I told you that when we multiplied them, you got 0? Again, either the first number or the second number is 0, because that's the only way to multiply two numbers together to get 0. So what we know then is that either the first number or the second number equals 0. So if you have an equation where this number times this number equals 0, then either x minus 3, the first number, equals 0, or x plus 1 equals 0. So what I just did was I set each factor equal to 0. And then once you do that, you solve. So that means if I add 3, these are like little baby equations. So x could either equal 3 or x could equal -1. Now, why is that? What does that mean? Well, if x equals 3, then what is 3 minus 3 times 3 plus 1? Does that equal 0? Well, 0 times 4, does that equal 0? Yes. So that's true. X could be 3. It also could be -1 though, because try this. So -1 minus 3, all I'm doing is subbing these numbers in for x, by the way, if you weren't sure, times -1 plus 1, does that equal 0? And also notice I'm using the same number for x. Like in this case, x equals -1, or in this case, x equals 3. Sometimes people think you use 3 for one of the x's and -1 for one of the x's or whatever, but it has to be the same number because x is the same letter, so it has to be the same value. This would be -4 times 0. Does that equal 0? Yes, -4 times 0 does equal 0. So whether x is 3 or -1, I would get an answer of 0. You could pick another number. You could pick 5. Like, what if you tried 5? what if x equaled 5? You would get 5 minus 3 times 5 plus 1. Does that equal 0? 2 times 6 does not equal 0. So that's not an option. And also, I just came up with 5 randomly just to show you that these numbers were significant, because these are the only two numbers that make that product 0. So that's how you do this, basically, is you have your equation set equal to 0. So notice that this equation, first of all, it's an equation, right? I've got an equal sign in it. And it's set equal to 0. So we love when it's already set equal to 0, but there are times when we're going to have to do that. So here we have an equation set equal to 0, and I'm going to set each of the factors equal to 0. Because either x minus 5, either that equals 0, or this number, 2x plus 3, I don't need parentheses, equals 0. And either way, it'll make this product be 0. So either, add 5, either x equals 5, or minus 3, 2x equals negative 3, divide by 2, ooh, a fraction, negative 3 over 2. So x could either equal 5 or x could equal negative 3 over 2. These are our two answers, 5 or negative 3 over 2. And again, you could check that. You could plug them in if you wanted. This next one, we've got this number, this factor, times this factor. And when they're multiplied together, they get 0. So either the first one equals 0, or the second one equals 0. And then you solve. Minus 1. So 4x equals negative 1. Divide by 4, divide by 4. I'll slide this up. So either x equals negative 1/4, or negative 5 minus 5. 3x equals negative 5. Divide by 3. X equals negative 5 over 3. So these are our two possible options for what x could actually equal. Those are the only things you could plug in. And I'm going to do it just because I love fractions. But if I had 4 times, we'll try the first one, negative 1/4 plus 1. So this times 3 times negative 1/4 plus 5. Does that equal 0? This would be negative 1 plus 1, that's 0, times, now this is going to be a mess. This is going to be ugly. Negative 3 over 4 plus 5, you need a common denominator. But you know what? It doesn't matter, because whatever this number is, which would be, what, 20 over 4, so it would be 17 over 4 times 0. Does that equal 0? Yes, because anything times 0 equals 0. So as soon as you get one of the factors to equal 0, you're going to get 0. You don't have to go through all that, but I just wanted to show you that it did work. Okay, so here are our steps. If you get confused, come back to this and check out the steps. So you have to get all of the terms to one side so that it's equal to 0, so that there's only 0 on one side. So you always need to move everything over and set it equal to 0. It's best to then put it in descending order, so like x squared and down, x squared, x, nothing equals 0, because then we have to factor. So all the ones that we just did were already factored. Now we're going to actually have to factor them, which is why you learned how to factor these last few weeks. Then you're going to set each factor equal to 0, which is what we've done above, and then solve for x, which is what we did above. So these last two steps we've been doing. All we're going to do now is add to it the factoring part. All right, so this first one, x squared minus x equals negative 6. So first note that this is an equation. Note that this is an equation. I will be asked this question a million times probably. How do you know when you have to solve it? And the answer is when it's an equation. So we have to solve for x. So if it's not an equation, you don't have to do all of this. You just have to factor and you're done. But if it's an equation, you have to do this part, this solving for x. So I'll tell you when the difference comes in. So this is an equation. So we're going to solve. The first thing we have to do is set it equal to 0. So I'm going to add 6 to both sides. Now I can't add the negative 5x and 6 together because they're not like terms. But it is written underneath it, so I hope that's not confusing. So now it equals 0. So I just did step 1. I set it equal to 0. Is it in descending order? Is it x squared to x to 6? Yes. So that means that just sets it up nicely for me to factor. So now I'm going to factor this into what times what is 6 and added together is negative 5. Well, I could do 1 and 6. I could do 2 and 3. So let's see. If I did 1 and 6, I'd have to have negative 6. But 1 times negative 6. So that would work for adding, but multiplying, it wouldn't, because that would be negative 6, right? So what if I did negative 2 and negative 3? Negative 2 plus a negative 3 gives us negative 5. And when you multiply those together, you get positive 6. So it's x minus 2 and x minus 3 equals 0. This is where you have to keep going because it's an equation, because it equals 0. Otherwise, we'd just be done. We'd say x minus 2 times x minus 3 are the factors. But now we have to solve. So you set each factor equal to 0. Set each factor equal to 0. So either x minus 2 equals 0 or x minus 3 equals 0. And then you solve each for x. So I add 2 to both sides to get x by itself. X could equal 2 or x could equal 3. Now you might notice, hey, those are the opposite of the numbers. Yes, they are. And sometimes it'll be like that, and sometimes they'll be fractions. So just be careful. But yeah, that is true. So what are our two options for x? 2 and 3. Those are the two numbers that make this possible. All right, let's try another one. 6r squared minus r equals 2. So this is an equation. So what does it mean? When it's an equation, we have to solve for x. So see this equal sign? That's a major indicator of what we have to do here. So first we got to set it equal to 0. So 6r squared minus r minus 2 equals 0, right? Because you just subtract 2 from both sides. So now it's set equal to 0. Is it in descending order? Yes, it is. It goes r squared to r to the first to no r's equals 0. So now I factor. So when I factor, the first thing I look for is there a GCF? No, there's not. Remember, in the middle, that's a 1, so there's nothing common in those factors. Now, I got 6 in the front. No big deal. I do AC factoring, so I do a times c. So, and then step 3 is to divide by a, so don't forget that. So I do 6 times negative 2, and that is negative 12. So what times what is negative 12, and added together is negative 1. 1 and 12, 2 and 6, 3 and 4. Yeah, 3 and 4, because they're like 1 apart from each other. So if it is positive 3 and negative 4, that gives us negative 1. No, that doesn't look like negative 1. That gives us negative 1. And then also, if I had a negative here, that would give me negative 12 if I multiplied them. So those are my two numbers. So I noticed that several of you were doing it by grouping, which is cool. You can totally do that. So I'll actually do it by grouping, and then I'll do it the way I do it. So if you have 6r squared plus 3r minus 4r minus 2 equals 0, you factor out a 3r, so you're left with 2r plus 1. And you have to take out a negative 2 here, so then you're left with 2r plus 1. And then you have 2r plus 1 times 3r minus 2 equals 0. All right, now that's the grouping way that some of you were doing in your homework. The way I do it is I say, okay, I've got r plus 3 and r minus 4, and then I have to divide those by 6, and I reduce. I know 3 and 6 reduce to 1/2, and 4 and 6 reduce because 2 goes into both of them, so it would be 2/3. Any denominator I have goes up in front of the r, so I have 2r plus 1 and 3r minus 2. So you see, these are the same answer regardless of the way you do it. Now comes where we have to actually solve because it's equal to 0. So I gotta tell you what actually r could be. So now we set each factor, so 2r plus 1 equals 0, or 3r minus 2 equals 0. So what does the value of r have to be? Well, if I subtract 1, 2r equals negative 1, divide by 2, divide by 2, r equals negative 1/2. Or, add 2, 3r equals 2, divide by 3, divide by 3, r equals 2/3. So we had fractions, negative 1/2 and 2/3. So can we have fractions as our answer? Absolutely, that is possible. All right, now it's an equation. So we've got to set it equal to 0. So I can minus 26p minus 26p. And I'm going to put that in the middle because I want it in descending order. So 4p squared minus 26p plus 40 equals 0. Is there a GCF? 2, all those numbers are even, right? I could take 2 out. So if I take a 2, if I take a 2 out, I have 2 times 2p squared minus 13p plus 20 equals 0. Now I still have 2 in the front, so I have to do AC factoring. So I have to do 2 times 20, and that's 40. So what times what is 40? And added together is negative 13. 1 and 40, 2 and 20, 4 and 10, 5 and 8. There we go, 5 and 8. So negative 5 and negative 8 will give you negative 13. And a negative times a negative is a positive. So if you want to do grouping, you've got 2p squared, and you got to keep your 2 out here in front. 2p squared minus well, if you do 5p, that's fine. And then minus 8p, and then plus 20 equals 0. So then you'd have 2, and then what can you take out of those? P. So 2p minus 5. And then here you can take out a negative 4. And so then that would be 2p minus 5 equals 0. So then you've got 2, and then p minus 4, and then 2p minus 5 equals 0. Okay. So you can do it like that. Or the way I would have done it, I would have had 2, and then p minus 5, and then p minus 8 divided by 2, which was our a. And so then this would be 2 times 2p minus 5 and p minus 4. So regardless, you get the same answer either way you do it, but we've got to solve for our p. So either you set each factor equal to 0. Now 2 is a factor, but does it have a p in it? No. So you set any factor that has a variable in it equal to 0. To say that 2 equals 0 doesn't make sense. So then I'm going to do it up here. So we've got 2p minus 5 equals 0. and p minus 4 equals 0. So either at 5, 2p equals 5, either p equals 5 over 2 or p equals 4. So those are your two answers for what p could be. All right, next example. Oh my goodness, this is only two terms. This is the difference of two squares. Remember, dots, difference of two squares. 16 is a perfect square, 25 is a perfect square. There's no GCF, so this factors into, and it's a difference, remember that, 4m minus 5 and 4m plus 5. Those are called conjugates, equals 0. So either 4m minus 5 equals 0 or 4m plus 5 equals 0. So 4m equals 5, m equals 5 over 4, or we subtract 5 and we get 4m equals negative 5, m equals negative 5 over 4. So 5 over 4 or negative 5 over 4 are the two options there. Okay, doing well. This next one, ooh, these, 121, I recognize that. That's 11 times 11. And this is a perfect square. This is a perfect square trinomial. And if you don't recognize it, that's okay too, because no matter what, if you say what times what is 121 and added together is negative 22, it's negative 11 times negative 11 and negative 11 plus negative 11. So you would have z minus 11 and z minus 11, which that's the same thing, right? So, so if you have that, what does that mean? If they're the same, well, either z, your only option is for z to equal 11. The fact that it equals 11 twice, you don't have to write that. You use that more in Algebra 2. You'll learn more why that matters, but you can just write z equals 11. That's it. That's the only option that z could be. Now, this next one has something cool that we haven't seen yet. One, it has a GCF, but that GCF includes a variable. So I can take 6z out of this one, and what am I left with? Z squared minus 1. So I can factor the z squared minus 1 because that's the difference of two squares. 6z times z minus 1 times z plus 1 equals 0. Z squared is a perfect square, 1's a perfect square, the minus in the middle makes it a difference. That's the difference of two squares. So now I'm going to set each factor with a variable equal to 0. So 6z could equal 0. Z minus 1 could equal 0. Z plus 1 could equal 0. So there are three options for z. And actually, that's not a surprise when you know that this, if that's cubed, guess how many answers there are? 3. So here, if you divide by 6, you get that z equals 0. So z could just straight up be 0. But it also could be 1. And it also could be negative 1. So you have 3 answers for this problem. 0, 1, and negative 1. All right, now we've got some examples for you to try. So what I want you to do here is pause the video and then unpause it and see if you got the correct answers. All right, so what we need to do here is it will be p squared plus 8p plus 7 equals 0. So I add 7 to both sides to set it equal to 0, and then I factor, so it's p plus 7, p plus 1, so p could equal p plus 7 equals 0, negative 7, where p plus 1 equals 0, p equals negative 1. So negative 1 and positive, or negative 7, This is the difference of two squares, m plus 10, m minus 10, 0, m plus 10 equals 0, m minus 10 equals 0, so m could equal negative 10, or m could equal positive 10. This one has a GCF of x, so I'm left with x squared minus x minus 6, x, so what, 2 and 3, so negative 3 plus 2, so x could equal 0, x minus 3 could equal 0, or x plus 2 could equal 0, so x could just be 0, x could be 3, or x could be negative 2.